All right, let's continue with example 4 from our logs lesson. These ones are asking you to solve equations, which really some of them aren't going to be all that different from the ones you saw up above. Um, and again, these are all ones that I would expect you to be able to do without a calculator. So really for most of these, my first instinct is going to be to move these around into exponential form and see what I can do with them from there. So this one here, it does not have a base listed. Okay, so we're going to assume that's a base 10. And if I were to put it back in exponential form, really what I'm saying here is 10 to the power of what makes 100. And that's one that I'm, again, expecting that you can just come up with off the top of your head. Really, this question, had I not had an equals x there, could have shown up in this section that was up above with example 3. Okay, I could have done that same type of question there. It just happened to have an x in it. So we're going to say x equals 2 because we would need an exponent of 2 to turn a 10 into a 100. So when I go to do this next one, again, I'm assuming that's a base 10. If I spin this around, I get this, 10 to the power of negative 3 equals x. So this one is a little bit different in that I'm not looking for what the exponent is. I'm looking for this value. I just need to figure out what 10 to the negative 3 power is. So for 10 to the negative 3 power, ultimately you're going to pick up on some shortcuts with these powers of 10. But let's start with one that you know. You should know that 10 to the first power is 10, right? And 10 to the second power is 100. We kind of just talked about that up above. Going backwards then, 10 to the power of 0 would be equal to 1. So look at what's happening here. We went from when it was 10 squared, we had 2 zeros. 10 to the first, we had 1 0. 10 to the 0, we had no zeros. When I go backwards into negative territory, I'm going to lose another decimal place here. So another way I could think about this is that my decimal point is moving in towards the left every time. So 10 to the negative 1 is 0.1. Okay, so notice that 1 is right after the decimal place. 10 to the negative 2 would then be 0.01. And 10 to the negative 3 would be 0.001. So when you're working with positive powers of 10, the power tells you how many zeros you're working with. When you have a negative power of 10, really that's telling you how many decimal places you need after the decimal place. So 10 to the negative 3 has 3 decimal places. The 1 is in that third place, and then you've got 2 zeros before that. So if I had to do this 10 to the negative third without a calculator, I would want to make sure I know that it would be 0.001. And if I had to, I could start writing some of these out to kind of get the pattern established to figure out what that is. Okay, next one. Spin this around. We get x squared equals 49. It's hard to see over my hand there. So what does x equal? Normally I would make you tell me that x could equal positive or negative 7. But logarithms can't have negative bases. So if you look at where that x is located, I couldn't have a negative number down there. So we would just say that x has to be 7. And then one more, spin this one around, and we end up with 3 to the power of 5 equals x. This one is very similar to the second one in that I just have to figure out what 3 to the power of 5 is. That might be pushing it a little bit without a calculator, but I think you could do it if you had to, if push came to shove. I think you could go 3 times 3 times 3 times 3 times 3. It should be 243. All right, that's it for that section. Let's just talk quickly about this example 5, and then we should be good for today. Between what two consecutive integers is log of 678? So remember that when I ask you for log of 678 and there's no base there, I'm really asking 10 to the power of what makes 678. But I don't have to figure out the exact power because I know it's not going to be something exact. All right, I could probably use my calculator, but I just have to know what it's in between. So think about this. 10 to the first power is 10. 10 to the second power is 100. 10 to the third power is 1,000. And so we need to know, where does 678 fall? Okay. 678 falls somewhere between 100 and 1,000. So that means the value of that exponent is going to be somewhere between 2 and 3. Okay, somewhere between 2 and 3. That's how I would answer that question. Between which two integers? It's between 2 and 3. Now, that one would actually work in a calculator, okay, because it's a common log. So I could just type in log of 678, and my calculator is going to tell me 2.83, which is, in fact, between 2 and 3. Next one we're not going to be able to use our calculator for so much, but so in this one, really what I'm asking is 2 to the power of what makes 50? So let's try to think of a power of 2 that's lower than 50 and a power of 2 that's higher than 50. And I kind of jump in at 2 to the 5th power is 32. But 2 to the 6th power is 64. So since 50 falls between 32 and 64, I know my exponent must fall between 5 and 6. And since we can't do log-base 2's in our calculator, I don't have a real good way to check that, other than you could start raising 2 to some powers between 5 and 6, some decimals there, and see how close to 50 you can get. But you don't really have to do that to answer this question. Okay, so that's really it for today. I do believe I have a textbook assignment that you guys are going to be working on now that you've completed this lesson. Give those problems a try. When you come in tomorrow, you'll be able to check your answers to the homework and then move forward with some graphing stuff that has to do with these lessons. Okay? All right, have a great night.